Welcome to the new lecture series of short but effective information on natural and synthetic materials for refractories. I will discuss about 43 materials to understand how one can pick up appropriate material for a particular refractory development. For more details, you can contact in this email. 1000 classic literature are available, but this information describes brief reasoning and understanding of materials to select, process and produce refractories. The list of materials has been encountered after discussion with several industrial personalities. Still, if I miss any one of them, please write in the comment section. I will try to describe them in the future. Before selecting a material list, knowing the type of refractories for iron and steel making is essential. This base hexagon corner point has 6 oxides 1, 2, 3, 4, 5, 6 and their connectivity points indicates carbon. We can obtain any refractories for the iron and steel making process with any permutation combination of oxides and their percentages, or it may be combination with carbon. Thus, we need several natural and synthetic materials. The list is in the next slide. Different materials are bunched together based on their constituents or properties or similarity in crystal structure. We will start with very common aluminosilicate materials, including low and high enriched alumina, synthetic pure alumina and many more. Basic oxide based materials are listed in column 2. Spinel and zirconia based material are also here. Binder are listed in column 3 and some specific materials. Essential constituents for carbon based refractories are listed in 4. Silica based raw materials are and dispersion agents are listed in 5. This is silica, these are the dispersion. Each material will be discussed for 5 to 6 minutes on the perspective of beneficiation or processing, color, texture and visualization, chemical analysis and properties, crystal structure and size, and XRD pattern, and eventually I want to emphasize why that particular raw material is beneficial for particular refractory development. Among iron and steel making refractories, here I picked up different grades of refractories for steel making. These all. Despite direct material selection, waste utilization is at the forefront of reducing the carbon dioxide footprint. In the future, we have enormous scope to identify properly spent refractories and their smart processing for converting them into valuable materials for refractory. So we can pick up the exact material for valuable raw materials and subsequent processing of refractories. Despite particle size distribution, particle surface modification is a good choice to enhance the flowability and dispersion. In brief, the chemical and physical methods may be adapted for the same. For example, the chemical method prefers the addition of several chemical constituents during particle processing. Glidants like silica sol are additive substances that enhance the flowability of a powder by reducing the interparticle friction, surface charge and cohesion, which in turn decreases the angle of response. The main approach to obtain thermodynamical stable dispersion of ceramic particle involves surface functionation with their surfactants, carboxylic acid with long aliphatic chains, polymers or other small organic molecules. The physical method also facilitates the surface modification and subsequent particle properties. There are several physical methods can be adopted for this purpose. In brief, I am ending this lecture. I appreciate your patience. Thank you.